Welcome to the 5th video of this video series. In this video, we will show you how you can create the ploil in two different ways. First, we use the functions learned so far. After that, we will learn an efficient method that takes advantage of the symmetry of the ploil. In doing so, we use the new functions mirror in Sketch and mirror bodies or elements. Additionally, we learn to draw circular arcs directly with the line tool, create arc segments with the arc tool, and adjust the order of elements in the construction sequence. We start as usual and begin the sketch on the XZ plane. In our sketch, we now use the slot center function, which we find under Create Slot. We place the first midpoint at the origin and draw the slot vertically upwards. We enter a length of 35 mm divided by 2 and confirm the input with the left mouse button. Then we enter a width of 8 mm and confirm with the Enter key. Now, we draw a circle at the lower center of the slot with a diameter of 4 mm. Next, we create another circle at the upper end of the slot without immediately setting a dimension. We apply the dependency right away and select both circles. As a result, the upper circle automatically takes the diameter of the lower circle. The upper circle is therefore dependent on the size of the lower circle. If we change the diameter of the lower circle, the upper circle adjusts automatically. To complete the contour, we create two rectangles on both sides of the slot. For this, we select rectangle with 2. We move the mouse to the outer line until the snap, the small blue cross, is displayed. Once the catch is activated, we click with the left mouse button and drag the rectangle apart. While pulling the rectangle, we enter the height as 23 mm and the width as 2 mm. We confirm the input with another click of the left mouse button. We perform the same process on the opposite side, except we do not enter. To align both rectangles at exactly the same height, we select the collinear dependency and click on the top edges of the two rectangles. We can now link the rectangle with the other, using the equal dependency. To make the sketch symmetrical, we now use the symmetry constraint. First, we select the top and bottom sides of one of the rectangles. Then, we make the origin folder visible in the browser and select the x-axis as the symmetry line. This aligns the rectangle perfectly symmetrically. We now also see a new line that serves as a reference to the x-axis. After this step, the entire sketch is fully defined again, which we can recognize by the black lines. We finish the sketch with the shortcut E and directly open the extrusion tool. We select the contour, excluding the two rectangles and circles, and set an extrusion thickness of 3 mm. Lastly, only the 4 fillets are missing. For this, we select Fillet, click on the 4 edges to be filleted, and enter a radius of 8 mm. The geometry of the component is already complete this easily. However, before we finish the component, let's take a look at an alternative method. You are welcome to follow the steps directly to discover new functions, or simply fast forward if you wish to skip this part. First, we remove the created body by right-clicking it in the browser and selecting Remove. This ensures that the body is gone, but the steps in the construction history remain visible. We start again with a sketch on the XZ plane and first draw a vertical line from the origin upwards. For the length, we enter open parenthesis 35 plus 8, closed parenthesis divided by 2 mm and confirm the entry with Enter. We then mark this line as the center line. We select the line tool again and start drawing a line from the origin. First, we draw a horizontal line to the right with a length of 2 mm and confirm it with a left mouse click. Then, we draw another line at a 90-degree angle vertically upwards. Here, we enter 23 divided by 2 mm as the length and confirm the input again with a click. Now, we draw the line horizontally to the right again with a length of 2 mm and confirm this line with the left mouse button. In the next step, we draw the line further upward and input for the length. Open parenthesis, 35 minus 23, close parenthesis, divided by 2, and confirm again with the left mouse button. For the next line, we click on the end point of the last line created, hold down the left mouse button, and draw an arc to the end point of the first center line. Next, we go to the Create menu, choose the option Arc, then select Center Point Arc. We click on the center of the arc segment, enter a radius of 2 mm, and start at the midpoint. We then draw the arc over 180 degrees until the midpoint reappears. The arc is confirmed with a left click. Before we start mirroring, we also turn the bottom line into a center line. Now, we have two options available. Either we mirror the created contour directly in the sketch, or we first create a body and then mirror it afterward. We select the Mirror command under Create and mark all lines of the sketch by holding down the left mouse button. At this point, we should definitely click on the center lines again to deselect them. Otherwise, they will be duplicated at the same position by the mirroring. As the mirror axis, we select the previously created center line on the Z-axis. After selection, we confirm the process with OK. Now we perform the mirroring process again, but this time we mirror the lines along the Y-axis to complete the entire contour. Then we extrude the sketch with a thickness of 3 mm. To learn about mirroring bodies, we will now undo the last steps by using the shortcut Ctrl plus Z. First, we now extrude the first quarter of the connecting rod contour with a thickness of 3 mm. Instead of mirroring the sketch, we now mirror the body. For this, we select Create Mirror and mirror the extruded quarter body along the YZ plane. Mirroring bodies or features is a more stable and less error-prone method because it is based on already calculated geometries and does not create additional dependencies in the sketches. This keeps your sketches clearer, more flexible, and more robust, even with later changes. Now we can mirror again, but on the XY plane.
We could now round off the four inner edges of the connecting rod. Alternatively, we can move the transition marking behind the extrusion of the quarter body in the design process and add the rounding there.
If we move the timeline marker back to the end, the filleting will automatically be integrated into the mirrors. We do not need to adjust the material of the component since it is made of steel. Thus, we are finished. In this video, we have constructed the connecting rod of our air motor in two different ways and got to know some helpful functions. On the first path, you use the slot tool to shorten the drawing of the contour. On the second path, you learned a bit more. You can now draw circular arcs both quickly using the line tool and precisely with the arc tool. You can also efficiently create symmetrical contours through mirroring. Finally, you learn to adjust the order of elements in the construction process to make changes and optimizations flexibly. Don't forget to save your component. Good luck with the upcoming tutorials.